Hey everybody, I'm Kevin today. I'm Kurtosis' CTO, and today I'd like to run through a couple of architectural things about Kurtosis that I've seen a couple points of confusion about. So I'll do some diagramming of the architecture of Kurtosis, why we designed it that way, and a couple of the interactions between the various different components. And then we'll close off this demo with a little bit of a demonstration of the CLI so we can see the actual architectural components in action. So go ahead and share my screen here, and we're going to come over to a Google Jamboard. So I'm a big fan of drawing stuff out. I really find that seeing something visually helps me a bunch. So Kurtosis has this concept of enclaves, and we developed Kurtosis initially to solve a lot of the challenges that we faced with distributed systems, both at our past work at Palantir, as well as in the blockchain space that we were working in. So an enclave is really a sort of isolated environment. It's like a little sandbox or a walled garden that you can do basically anything you please inside of. And the idea behind an enclave is that it's a level of abstraction that allows us to create and destroy things as a whole. So if I were to, for example, start an Ethereum network, and we can go ahead and represent that here with a couple nodes. This Ethereum network inside of the enclave here is completely encapsulated inside of the enclave. And it doesn't have communication with things that might, for example, be in another enclave. And you don't get any interference between them. So there's a couple identifiers that Kurtosis uses in order to identify the various services as well as ports that the various containers listen on. And if we, for example, had a near network over here, then we're not going to see any cross interaction between the two of these. And this is, of course, very useful for CI testing as well as when you're doing development. So anybody who's worked with Docker Compose knows that you sometimes get two Docker Compose files that you'd like to run at the same time, but they have a colliding port, and then you get a port conflict. Or you might see volume issues where two enclaves, or excuse me, two Docker Composes need the same volume name, and then you start getting conflicts there. So we really design enclaves to be completely isolated and contained. So these little nodes inside of the enclave, we call user services. And the fundamental feature of a user service is that it does not know it is running inside of Kurtosis. So from the services perspective, so if each of these are ETH nodes, right? These ETH nodes do not know that they're running inside of a container at all, in fact. Um, you have the ETH node, which listens on a couple ports, and then it could be running on your local machine, or it could be running inside of a container, or it could be running inside of Docker, or it could be running inside of Kubernetes. The ETH node does not, in fact, care. So from the Kurtosis side, what we do is we provide the machinery to hook these various things up together through a higher level abstraction, which we call the service. So each of these nodes is a user service that is identified by a service ID. And as we know, blockchains need a boot node in order to connect your other nodes. So we could call this node 0 here, and this could be node 1, and this could be node 2, which of course means that node 1 reads its information from node 0, the ENR, in order to start, and the E node for execution layer clients, and node 2 will do the exact same thing, where it will use the E node of node 0 in order to start. So these represent the identifiers that Kurtosis uses for the different user services here, the different Ethereum nodes. And if we happen to have a near network over here, because enclaves are isolated from each other, we could have the exact same user service IDs here without any sort of conflict. And that's not a big deal because these are separate namespaces here. Now, it's really it's cool that you can start these inside of an enclave. Sure, that's fine, but really you want to be able to do some interaction with these. It might be useful to just see your own little pet network running, but you really want to be able to interact with it from the outside world. And so as a result, Kurtosis provides you with a local port binding for all the different port bindings on the container to your machine. So if this is the boundary of the Docker engine, and this is your code that you're running on your machine, then actually these port bindings are going to be available to your local machine. And from your local machine's perspective, it's just as if the service is running like any other service. So this code that's running on your local machine, this could be a Go program, it could be Java, it could be Bash, TypeScript, whatever you please. You have the ability to connect to a port. And this port is going to be something high and ephemeral. So this might be like 97123, and this might be 97124. And the benefit here is that the port that this node is listening on gets bound to a local port on your machine. So this, quite technically, this would be, you would access this port at 127.0.0.1 or localhost on 97123. And then from your program's perspective, you can just connect to this as if it's any other service listening on your local machine, when in reality, it is in fact running inside of Kurtosis. Now, again, the benefit of having this enclave abstraction is that there's going to be near nodes over here, and they are also going to end up with ports that are available to your local machine. Again, these ports are randomly generated and they're guaranteed not to conflict. So let's say we were starting this near network at the same time as we were starting this Ethereum network. That's no problem. Kurtosis is going to make sure that you don't have any sort of conflict. And you might see that your ephemeral port numbers are really close to each other as your underlying operating system doles out the underlying ephemeral ports, but really not a big deal at all from your program's perspective. And a quick note about this program can be a test if you wanted. This is a very classic case of using Kurtosis to test stuff. So inside of Kurtosis, we actually use Kurtosis to test Kurtosis, and this could be Go test. So you might have a project that has a bunch of Go tests, and those Go tests through the Kurtosis machinery, through the Kurtosis SDK, would interact with the Kurtosis engine to create this enclave as well as the stuff inside of it. You'd get these local ports, and then your Go tests would contact the local ports in order to do the various things that you need to do. Now, I'm saying one port here, but that's a little bit of a lie because, as we know, these nodes might have several ports. And Ethereum, I believe Ethereum has 4 ports. It has the RPC port, it has the web service port, it has 2 discovery ports, 1 UDP and 1 TCP. So in fact, Kurtosis will handle binding all of those ports to your outside machine. So you would actually get 4 different ports here. So if we want to modify this, this might be 9764555 and 9768899. There you go. And then I'm running out of space here, but you'd have a 4th port as well. And each one of these would represent a internal port inside of the node. So from the node's perspective, it's just listening on the standard ports. So this might be 8545 for RPC for Ethereum, 8546 for the web service, 30303 for the discoveries, etc. from the node's internal perspective. And the other nodes behave just as if this is what was happening inside of the container. Because inside of this network here, these nodes are going to be connecting on those exact same ports. Each individual node behaves as if it were a separate machine while we're inside of the enclave. It's only when we go outside of the enclave that we start getting these ephemeral ports that get mapped to the internal or the private ports, is what we call them. So quick little review. You've got user services. User services are going to have ports that they listen on. You declare these when you start a service inside of Kurtosis, as well as the service ID for the service. And then Kurtosis will handle making sure that those ports are available to your outside machine, that they don't conflict no matter how many enclaves that you have started. So those are enclaves and those are user services. Now, if you wanted to actually set up this network, you would end up issuing a bunch of commands to the Kurtosis engine. So that could happen in your outside program. You might have the Kurtosis SDK imported in your outside program, and then you're chatting with the Kurtosis engine. And the Kurtosis engine is going to say, okay, cool, I'm going to create an enclave on your behalf, and then I'm going to start a bunch of user services inside of that enclave according to the various instructions that you give me. And as a quick little deviation, the Kurtosis SDK, this is available at the Kurtosis Engine API lib project right here. So Kurtosis Tech Organization and then Kurtosis Engine API lib. And this is going to contain all of our SDKs for interacting with the Kurtosis engine. So you would have that SDK here, and then you would communicate with the engine, and then you would start creating an enclave and doing things inside of the enclave, giving instructions to Kurtosis engine for nodes to start up inside of the enclave. Now, if you wanted to distribute those instructions to other folks, one option would be, of course, packaging this as a library and then saying, hey, folks, please import my library, and then call some function that you have in order to run the actual setup. And that's totally valid. However, that is language specific. So if you gave this to somebody and you said, hey, please run my Go library, they need to have the version of Go that you had, or the appropriate version of Go, or I should say your Go binary needs to be compiled for their architecture and for their operating system, for them to run it, and so on and so forth. So there's a lot of dependencies, a lot of extra work that the person has to do in order to run your outside program. So Kurtosis provides a second feature, which we call modules. And this is a module right here. Modules are identified by a module ID, which is in a separate namespace from service IDs. So you could have, technically, we could call a module node 1 or node 0, et cetera, and that would not be a problem for Kurtosis. Would be a little strange, but generally people will name their modules with some sort of more descriptive name. But a module is a packaged set of instructions using the Kurtosis Engine SDK. So the difference between a module and a user service is that, unlike the user service, which doesn't know anything about where it's running, it's running inside of, it could be running inside of a container or Kubernetes or anything like we already said. A module actually contains a connection to the Kurtosis engine itself. So concretely, this means that inside of the module, inside of every module, is the Kurtosis SDK, which allows the module to make requests for modifying the enclave that the module is running inside. Modules cannot run outside of an enclave. Again, this is off of the fundamental principle of Kurtosis that enclaves should be isolated walled gardens. And modules cannot modify things outside of their own enclave. So this module is not able to start affecting the things that go on inside of this module. So again, our enclave provides the boundaries of what can happen. And this module right here could encapsulate all the steps for setting up this Ethereum network. And the benefit of this is that this module would be a container. So a fundamental rule of Kurtosis, or a design principle of Kurtosis, is that everything inside of Kurtosis is a container. So we do this for a couple of reasons, but the principal one is that so users can write in whatever language they please, and then have the parts interoperate with each other. So this module, for example, could be importing our TypeScript SDK and defining the logic for setting up an Ethereum network by issuing a bunch of commands to the Kurtosis engine for start node 0, and then start node 1 using the enode of node 0, start node 2 using the enode of node 0 as well. And this can be written in TypeScript, while these fundamental nodes are written in whatever you please. These could be Geth nodes, these could be Bezu nodes, etc. And by having a module packaged as a container image, we get the benefits of containerization and the ecosystem that's been built around that. So that means that users can distribute their modules to other users via Docker Hub. You get the local caching that's already built in with Docker and pretty much every other container technology out there. So you can pull it down locally, and then you don't have to constantly pull it from the internet repeatedly, et cetera, which is a little bit trickier if you were to use a classic build tool, and of course doesn't have any dependencies on the user having anything running on the machine. And then, of course, I'm just repeating the benefits of containerization right now, but you can package any OS you want. So the idea here is that a module is more like a productized set of steps. It's really a packaged, encapsulated chunk of logic to the Kurtosis engine. It differs from a user service in that it actually knows that's running inside of Kurtosis and has the ability to affect things inside of Kurtosis. Now, we talked about user services, and when we've talked about services, we've talked about services in quite a classic sense. So you have a server that provides some endpoints that allows you to do things with that endpoint, again, exposed to your external computer. But those services could also be, for example, a front end. And from Kurtosis's perspective, this is not a problem. So we could start an Ethereum Explorer as a service here, give it the service ID of Explorer, and have it connecting to the nodes in the Ethereum network. And the benefit here is that if we were to package this Explorer setup logic in the exact same module right here as the rest of this logic, then we'll get the exact same benefits. Kurtosis will expose the port to the outside world. And now I will be able to open my browser and visit an Explorer, which is running inside of Kurtosis and connected to the Ethereum network that is also running inside of Kurtosis. And this is kind of where modules are pretty cool, because you have basically a chunk of logic that you can give to folks to do things inside of Kurtosis, and they can be arbitrary. Because launching a module inside of Kurtosis is just an SDK action, there's an SDK action of load module inside of an enclave. Well, you can start doing crazy things, like if we had this Ethereum network and we wanted to test a bridge to, say, Avalanche, here, where we need to set up an Avalanche network, we could have our module. Let's go ahead and call this ETH Ava bridge module. We could have this import an Avalanche module that encapsulates all the setup of running this Avalanche network. And our Ethereum module, our ETH Ava bridge module, would just call down to the Avalanche network, set that up, do all the logic for setting up the Ethereum network, and then any sort of extra work that's needed to create the bridge contracts and so on could be done inside of Kurtosis. So that's the high level overview here. We have enclaves, which are sort of the walled garden, the fundamental unit, the little house to put things inside of. We have user services, which are the elements really under test, which are inside of the enclave. And then we have the modules as well here, which are packaged chunks of logic to the Kurtosis system. You can modify the Kurtosis system both inside, if you're a module, for example, or from the outside by just importing the SDK directly on some program on your local machine and communicating directly with the Kurtosis engine. And you can have arbitrary numbers of enclaves running at once, of course, limited only by the resource constraints of your machine. And then all of this happens inside of Docker. Now, I talked about the Kurtosis engine. And we have the SDK here, which is communicating with the engine, and then we have the module, which is communicating with the engine. So concretely, what does that mean? There is a special container that does not run inside of an enclave, which is the Kurtosis engine container. And very concretely, that is a gRPC server that listens for commands. So when you use the Kurtosis SDK, either inside of a module or inside of code that's running outside of Docker, you are running a client that is communicating with the Kurtosis engine and issuing instructions. So if I come over to my Docker over here, we can see that this container right here, this is the Kurtosis engine. So that's the high-level overview of the Kurtosis concepts, the architecture. There's a couple finer points. There's a couple cooler things that you can do. But I'd like to jump over into the demo now and show you a little bit about how Kurtosis actually works. So seeing these concepts in practice. So again, Kurtosis is interacted. The main mode of manipulating Kurtosis is via the SDKs. And that's fine, but not everybody wants to write a whole new project in a whole new language and deal with setting all that stuff up. So we provide a Kurtosis CLI. So this is the Kurtosis CLI. You can go ahead and install that using your favorite package manager. And very briefly, if you go to docs.kurtosistech.com, scroll down to the installation, you'll see installation steps for installing this as well as upgrading this in the future. I'm running on Mac, so I use the homebrew step, just a single one-liner, and then you'll magically get the Kurtosis CLI available on your machine. So we talked about enclaves, and Kurtosis has Kurtosis Enclave LS, which is going to show the enclaves that are running inside of your Kurtosis engine. So I have one enclave right here. We can see that the enclave ID is the unique identifier for an enclave, as well as the status that's going on. And if I do Kurtosis Enclave inspect using this enclave ID, we're going to see a little bit of information about this enclave. So this is actually a mostly empty enclave. This is the section for user services, and we can see there's no user services, as well as modules, and we can see that there's no modules. I'll come back to interactive REPLs in a little bit. We'll see those in action. I'm going to hold off on explaining those for now. So if I wanted to create a new Kurtosis enclave, I could do Kurtosis enclave new, and this is going to create a new empty Kurtosis enclave for me. And once this comes back, we can do Kurtosis enclave inspect and see that we have a completely empty enclave inside of here. Now, if I wanted to start doing stuff, if I wanted to start populating things inside of the enclave, there's a couple ways that I could do it. So the simplest way is if somebody has already provided you a module, if they've already published that module up to Docker Hub, then you can go ahead and execute that module using your Kurtosis CLI. So if you do Kurtosis module exec, Kurtosis tech / near Kurtosis module, this is going to execute the near Kurtosis module, which sets up a near network. So you can see that we're pulling down the module image here. Again, modules are just, they're backed by images, they become containers. And then we can see that there is a new enclave that is getting created here. And then down here, we're actually streaming the logs of the module container itself. So if I go over to my Docker engine, and then we see this my module here. Let's expand this for a second. You see this my module here. That's just the module ID that we give to any module that is executed via that module exec command. And then if I go ahead and open here, we can see that the exact same logs that are showing up inside of this container are getting streamed to the CLI right here. And now the module is finished, and it returns a bunch of output to us. You can think of a module like a function. So it takes in some parameters here, some JSON parameters. It does some logic, and then it returns an output as JSON. And we can see a bunch of information about what the module actually did. So this is actually the near network name. We see the root validator key, and then we see a bunch of URLs here. So just like I mentioned in my diagram here, we have an explorer, and then that gets bound to a local port. In this case, we see that we have a bunch of different publicly available ports running on 127.0.0.1. And if we were to go ahead and open this here, we'll see that we do, in fact, have a near explorer. And this is connecting to the public port of an explorer that is actually running inside of the enclave. And we could do all sorts of crazy stuff here. And then we actually have a wallet as well. So if we wanted to go ahead and create an account, I can go ahead and do that. Because this is a private testnet, I don't have to deal with anything. I don't have to deal with any name collisions or anything like that. So I won't go through that. We actually have a video of doing the near module deep dive on our Loom. So today I'll keep it a little more general. And then if we go ahead and do Kurtosis enclave ls again, we see that there is now a new enclave near Kurtosis module here. We can do Kurtosis enclave inspect, and we see a bunch of new information. So we see the module itself. We see actually the public port for accessing the module. Technically, a module is a gRPC server that responds to exactly one endpoint, which is the execute endpoint. So if you wanted to connect directly to the module, you could actually do that, and that would look like another little orange tunnel right here. We're connecting directly to the module. Let's say if you wanted to do some sort of debugging or something like that, that would be available for you. And then we see all these user services that the module started. And these are what's actually powering the near network. So we have various different things. So we got the wallet here, we got the Explorer front end, we got some backends here. I think this is part of the backend, if I remember correctly. And a whole bunch of stuff that the user doesn't really need to worry about. So this is the service ID right here. And this is the timestamp that the service was created to form the service GUID. And this gives you the ability, like let's say if I were to tell Kurtosis to destroy this service and then recreate the service with the backend service ID again, Kurtosis would allow that because you technically have two separate services defined by the time that they were started. So those service IDs that we talked about in here, they only must be unique at a given point in time. So you could destroy node 0, which would of course might break the rest of your Ethereum network, but you could destroy node 0 and then you could recreate a node 0 afterwards. Now we have this enclave, And again, if you created this stuff, you might want to tear it down. So if we do an enclave ls right here, we can see that these are the, this was the enclave that I started with. This is the enclave new that I created. And it's as easy as kurtosis enclave rm. I'm going to do a -f to say stop a running enclave. And now it's gone. Under the covers, what an enclave actually is built on top of the Docker engine right now. We can see that we actually have one Docker network per enclave. So again, this is enforcing the isolation between the different enclaves. And then when you delete an enclave, we destroy the Docker network, as well as a couple other things. There's a couple other backend machinery things that we deal with and create. Those get destroyed as well. Now, once you're at this point, if all you want to do, for example, is to do a little bit of dApp development, then this might be perfect for you. But depending on your use case, you might actually want to start investigating what's going on inside of this enclave. So that's what those REPLs are for. Inside of this enclave, I can go ahead and say, copy this enclave and say kurtosis REPL new this. And what this is going to do is it is going to pull down an image, which is our JavaScript interactive REPL. And again, because everything in Kurtosis is inside of in a container, you are going to launch a container, which contains a node REPL that is connected to the Kurtosis network, to the user services. So I'm getting a little crowded over here. So we're going to come over to this enclave. This is analogous to starting a new container here, which is our JavaScript REPL container. And then your CLI is going to be connected to this REPL so that you can issue commands in the REPL. And that would allow you to connect to the various things inside of this network. Now, like modules, REPLs know that they're inside of Kurtosis. So just in case you didn't want to deal with setting up the Kurtosis engine or downloading the SDK and all that stuff, this REPL actually has the Kurtosis SDK available to you. So this enclave context is the connection for modifying this enclave as a whole. And so if we do await enclave context dot get services, we can actually see all the service IDs that we started from up above. And of course, we could do things with those. So we could do all the JavaScript goodness that we want. I'm not personally very experienced with JavaScript, so I don't know exactly what commands I would need to run here in order to do the to make requests against these. I would imagine that I would end up importing the near client library, JavaScript client library, and then making requests here against these. But if this were, for example, an Ethereum network here, then it might be useful, for example, to have others. Now, this is a pretty bare bones node environment right now. It's running, again, inside of this container here. And it pretty much just has vanilla node plus the Kurtosis SDK available inside of the REPL. But we can go ahead and change that. So if we're pretending that this is, in fact, an Ethereum network, we can do a Kurtosis enclave ls. Helps if I spell it right. Kurtosis enclave inspect here. And now we see that this REPL actually got a GUID. So with that GUID, we can do some interesting things like Kurtosis REPL install, copy the enclave ID, copy the REPL GUID here, and say install others for us. And then Kurtosis in the backend will actually start loading others inside of this container so that it's going to be available for your CLI. And once that's complete, we're going to now have others available. So we can say others equals require others. And now we have others. And that would allow us to connect to the various services inside of the enclaves. So part of the reason that Kurtosis forces you to have unique service IDs inside of an enclave is because these actually become host names. So if you are inside of this network, then you can connect to this node by using the host name and the domain name. So a domain name of node 0. So if you just connect to node 0 or to node 1 or node 2, using that as the domain name, and then of course whatever port that this container is listening on internal to the network, then you can, for example, create an others client. You can create an others client that's connecting to the various Ethereum nodes. So that's kind of the little bit of one layer deeper for investigating a network. And because this is an enclave like any other, I could just as easily start manipulating it from outside the network. So this is a REPL that's running inside, and we are really communicating with it like this via our CLI. But again, I could have my external program start making requests against this network right here, and that's really not a big deal. So to kind of conclude this demo, just wanted to show off a couple other neat things that we have. We find the Docker CLI a little bit low level for our needs. So for example, if you do Docker container ls here, we get a bunch of information, which is cool, but then we got to copy our Docker container ID. And if we do Docker container inspect here, then we're gonna get a whole bunch of JSON, which contains a lot of kind of detailed information. And then if we do Docker container log, we're gonna grab that as well. We get back all of this. So with Kurtosis, we kind of think in enclave IDs and service IDs. So if you do Kurtosis enclave ls and you got a given enclave that you're looking for here, you can do Kurtosis service logs here. And then let's say we want to get this guy right here. And, we can pipe this to Vim. We could start investigating this. We could write this out the file if we wanted. This is what the wallet logs.txt, etc. Now, an extra thing on top of that, though, is that you might find a bug inside of your enclave. So maybe something doesn't work the way that you expect. Maybe you've found something strange, or maybe, for example, you're using a module that's developed by somebody else, and you see some weird behavior. Maybe you expect Node 2 to be set up, but it isn't set up, etc. You can run Kurtosis enclave dump with the enclave ID, and then say near enclave output here, and then, oops, let's do that. And then you're actually going to get all the information about this enclave packaged inside of this directory. And we can see that if we go inside of any of these guys, we can see a bunch of information about internals to Kurtosis. If we go into the wallet, and we can see the container inspect output, which is very useful for folks who are building their own networks. They might say, hey, what are the commands that you're running things with? And you can say, hey, these are the commands that I'm running the node with, etc. So we found this to be very useful when we were building the Ethereum merge module. Maybe we'd find a bug with one of the clients. Well, then we could just package this all up and send it off to a client developer. So that was a little bit of a walkthrough of the Kurtosis ecosystem. We have, there's a couple of features that I didn't show today. You can find those in the docs, or you can find those inside of playing around with the SDK. Everything on the SDK should be very well documented on our docs here. Come over to here, and we can say the Kurtosis engine API documentation. We can see that our Kurtosis context is the root object. You can do create enclave, get enclaves here, stop enclave, etc. And then for managing the stuff inside of an enclave, we have module contexts, right? We have loading modules, unloading modules, all the kind of stuff that you'd expect. So if you'd like to get in touch with us, get in touch with me or any of the Kurtosis team, our Discord is the best place to do it. Again, that should also be on our docs here. Yeah, right here. So this is the Kurtosis Discord server. You can go ahead and hit me up here. I'm Kevin on the Discord server. Feel free to ask me any questions or any feedback. We would really appreciate if you had any issues, if you have any friction points, please definitely reach out to us. We want to make the experience of developing distributed systems as easy as possible. And we definitely rely on you guys' feedback to very loudly tell us if stuff is broken. So we'd definitely appreciate that. Or if you're somebody who likes issues, GitHub issues, and you can go to Kurtosis engine API lib, GitHub, and file an issue here. So that was a little bit of a walkthrough of the Kurtosis architecture. We talked about user services, we talked about modules, we talked about enclaves, we talked about the interaction between your external machine and the internal machine. We showed off the Kurtosis CLI and covered a little bit of the cool features inside of that. So hope this demo was useful, and I will see you guys all in the next one.